Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 16, the last section, or last lesson in this section. Similar triangles in circle-secant or circle-secant-tangent diagrams. Okay, so opening exercise says, identify the type of angle and the angle arc relationship, and then find the measure of x. Okay, so pause the video, see if you can do these four, and then come back and see how you did. Okay, so number one, I'm going to just highlight these real quickly with a color so that we can see what we're dealing with. So here is the angle that we're given, 29 degrees, right here, and it intercepts this arc right here. So what kind of angle is that? So identify the type of angle and the angle arc relationship. So this is an inscribed angle. It's an inscribed angle, and its relationship is half intercepted arc. Okay, so x equals, so the half the intercepted arc. So actually the way we could write this is the angle measure 29 equals 2, or half the intercepted arc. Why am I writing 2? 1/2 x. So 29 degrees is half of this arc. So to solve this, we multiply both sides by 2. So therefore x would equal 29 times 2, which is 58 degrees. Okay, so there we have it. All right, B. All right, so this is an interior angle. Okay, it is not a central angle, but it's inside, and it is formed by two chords. So I'll say interior angle formed by the intersection of two chords. Okay, that's the identification portion, but then we want to know what their relationship is. So the angle is half the sum of the intercepted arcs. Okay, half the sum of the intercepted arcs. So what we're saying is we have this angle right here, which intercepts this arc. But we also have its vertical angle, which is congruent. So this is also 74 degrees, and this is its intercepted arc. So what I would say was the angle equals, so 74 equals x plus 62 divided by 2. Multiply both sides by 2, and we get 148 equals x plus 62. Subtract 62 from both sides, and we are done. So we get x equals 8 minus 2, 6. 14 minus 6 is 8. So that is 86 degrees. So the angle, so the arc BE is 86 degrees. Okay, continuing on, part C. Let me just clean this up a little. Okay, so here we go, part C. All right, well, C is an exterior angle. It is outside. It is formed by two secants. Okay, so an angle outside the circle formed by two, not T-O, not T-O-O, T-W-O, and those are secants. That is a C, secants. Okay, an angle outside the circle formed by two secants, that is right here, that is the measure of angle x. We want to focus on the two arcs it intercepts, which are BD and this one. This is 72 degrees, this is 35 degrees, and therefore the angle is half the difference this is an E, half the difference of the intercepted arc. Okay, so x is going to equal 72 minus 35 divided by 2. So x is going to equal 37 divided by 2. So x is going to equal 18.5 degrees. Okay, and then finally the last one. Angle BAD is a central angle. Okay, and central angles are equal to the intercepted arc. Okay, so when I look at this, they're marking this. Oops, I didn't want to draw over the X. They are marking, struggling with my pen here. This is the angle. This arc right here is the one that they're giving us. But these two angles are vertical, so this is also equal to X degrees, and they're equal to the intercepted arc, so X is going to equal 42.5 degrees. Okay, so there's those four. Okay, page 2 is also an exploratory challenge, so there's nothing new here. We are exploring something new, but we're going to come to a realization about something. So pause the video, see if you can fill this out, and then we'll check our values. So what it's saying is measure the lengths of the chords in centimeters and record them in the table. So we have A, B, C, D. So this is A, and then we want A, B, C, and D from each one of these. And then it says, do you notice a relationship? So here we go. So let me get my ruler. Now you're on paper. Just let me make things clear here. What I get here on the computer screen may be different than what you get on your paper, because when we convert to an electronic device, there may be a dilation of some sort. We don't know what R is, but it could be, it's not going to be 1. So just be aware that I might get values a little less than yours. So I'm using the centimeter side, and I have my 0 right here. I'm measuring C first, and it's measuring 29 centimeters. So you might get 30 or 31 or 28, I don't know. But on this one, C is 29 centimeters. So I'm going to put that right here. And then I'm going to measure over here, and D should also be 29. So if I put 0 right there, it actually comes out to be 29 or 30. Let me just go with 30 to make it easier. Maybe this one over here was also 30. Let me check it again. Let me check C. Yeah, maybe they're considering that 30. Maybe I was off a little bit. So let's make C 30 centimeters, and D was also 30 centimeters. And then when I rotate this way and bring down, first thing I like to do is line it up so that's parallel. And then I put my 0 right there, and it flipped on me. Okay, great. And so from 0 right there, so that's also 30, and that was B. So I'm assuming that that is the center of the circle. So these are all radii. So that is also 30. Okay, so 30, 30, 30, 30. Do you notice a relationship? They're all congruent. And the reason is that, well, their radius, their radii, if you will. Okay, they're all the same, in other words. All right, let's look at B now. So let me switch to green. And let's rotate this, and I'm just going to, it doesn't matter what order you do these in, I'm just going to do this one first because my ruler was closer to this. Okay, so there it's lined up. Bring the 0 up as close as I can. That's looking like right about there. And it looks like 35, 36, 37, 38. I will say 39 centimeters, and that is C. So that'll go here, 39. And then if I move this over to 0 here, that looks like it's 2 or 20 millimeters. And that is D. Oh, they're saying centimeters here. Okay, so let me fix this. Then, so if that is going to be 30 millimeters, then this is going to be 3 centimeters because there are 10 millimeters in a centimeter. And let me measure this one again. I'm thinking they're going to tell us it's 40. No, it's short. It's looking like 39. So C, I'm going to say 3.9. And then D is going to go from here. And that looks like 2. All right, let me just measure this one again. It's not 4, it's 39. Okay, 3.9. All right, let me rotate now, and then I'll measure A and B. So the first thing I do is I like to line this up so it's parallel. Obviously, it's going to be a different procedure for you on paper. And I measure this out, and A is 3 centimeters. And then if I move this over here, B is 2.5. So 3 and 2.5. Okay. And what's going on here? Not sure. So I just put a question mark. Now let's move on to the C one, and let's do A first this time. Move this down, make it parallel to AB like so. It's fairly close, but I want to be more accurate than that. All right, here we go. Maybe a little bit more too, right there. So here's 0. A looks like 15, 16, 17. And B looks to be about, let's see, this is really tough. 2.8. So A is 1.7, B is 2.8. And now let's check C and D. This is going to cause a problem, I think. Okay. Line it up. Here's my 0. And it's looking like 13 or 14. I'm going to say 13, 1.3. And then finally, this one here is 3.7. Okay. All right. So, So let's do some playing around here and try to figure some things out. So if I turn my calculator on, if I go up to B and I say 3 times 2.5, I get 7.5. 3.9 times 2, I get 7.8. So they're kind of close. So something's going on here. 1.7 times 2.8 comes out to be 4.76. 1.3 times 3.7 comes out to be 4.81. So they're really close. So I might be off a little bit by my measurement, but what we should be seeing here now is that A times B is equal to C times D. Okay. Again, my measurements may be off just a smidge. Okay, so let's try this one more time, and I'll use purple. All right, so first thing I do here, let's move this up to 0, rotate, and that is looking like 3.4. Okay. That is, oh, that's the whole thing, AB. A is 5, 6, 7. Yeah, it looks like 7 or 8. I'll put 0.7. 0.7. And the whole thing was 3.4. So 3.4 minus 0.7 is 2.4567, 2.7. All right. And then I'm going to shift this, rotate it. That looks about right there. Bring that up. And it's 3.4 here. And then measure D and we're done. D looks like 0.6, 0.6. So if I get my calculator out and check, see what A times B is, it will be 0.7 times 2.7. And that gives me 1.89. 3.4 times 0.6 gives me 2.04. Let me just double check those measurements. Yeah, that looks like 0.6. And let me check A and B again, because there's supposed to be something going on here. I already know what the rule is, so that's why I'm leaning towards it. And this is 3.4. So the whole thing, AB, is 3.4. So A is, it's hard to tell without my pen. Here, let's do arrow. That's not working. There, that'll work, this dot. So this is 0.5, 0.6, 0.7. Maybe that's just I do have 0.7 for A, don't I? Yes, 0.7. And this one here is maybe 2.6. Okay, anyhow. That's going to make it further away. 0.7 times 2.6 is going to be less than that. So let's say this was 2.8. What would happen? 0.7 times 2.8 equals 1.96. This is 1.89. So it's supposed to come out to be A times B equals C times D. I'm probably running into problems here because of the scaling. If you're doing this on paper, hopefully Engage New York has printed some so that it's really accurate and it's coming out so that A times B equals C times D, because that is the formula. All right, page 3 brings us to exploratory challenge 2. Measure the lengths of the chords in centimeters and record them in the table. Okay, this is really time consuming for me, so I'm going to measure the first one, but then we're just going to do it. I'll do it and bring my values in after. I don't want to spend the time. I think we all know how to measure stuff. So these are tangent or secants this time. They're not just chords, they are secants. And if I measure the length of A, that is from the angle point outside to the edge of the circle, which is right here. And in this case, that is 3 centimeters. So I'm going to put a 3 there. And then it goes all the way to 7. So 3 to 7 is a distance of 4. So there's A and B all at once. And then when I rotate this, I should get 3 again and 4 again. So that's 3 and 4. So what we're going to say there is everything's equal. So the product of A and B is equal to the product of C and D. So I'm going to say A times B equals C times D, which we also had prior to this. And I will pause the video now and I'll do all the measurements and fill in the table and discuss the relationship. Okay, so here are all of my measurements. So we've already done A. So now I'm talking about B. A was 1.6. B was 4.4. Totaling 6. From A to here was 6. Or from here to here. C was 2. And this was 2.7, which totaled 4.7. So this is longer than this, obviously. These two are equal, so we could say this. But if I check with my calculator, and if we try to do what we just did with the prior page and see that A times B equals C times D, let's check that. So if I say 1.6 times 4.4, I get 7.04, and then 2 times 2.7 is going to be 5 point something. So it's off by over 2, or almost 2, not quite 2. So that doesn't work. So we're just going to say right now products are not equal. So something's going on here that we aren't aware of. Okay, so we need to do some more investigation. All right, so it would be really difficult for you to figure out what is going on here. So I'm just going to cut to the chase. And what's going to happen here is we have a formula. And what we say is outside times the whole thing equals outside times the whole thing. So in other words, the outside is A. So A times the whole thing, which is A plus B. And be careful here. A lot of students multiply there, and that's a mistake. It's A times A plus B. So outside times the whole thing. The whole thing is one part plus the other part. So the outside for CD is the arc, or the is the segment that C is right here. Let me just erase this now. And so let me just do it this way. So this is the outside portion of that secant. So you take the outside C and multiply it by the whole thing. Well, what's the whole thing? It's C plus this D portion. So it's C times C plus D. So then if I take my calculator and check that, watch what's going to happen. A, which is 0.8, times 0.8 plus 4.2. 0.8 plus 4.2. Okay, so that's the outside times the outside plus the inside, and I hit enter and I get 4. I do the same with 1.1 and 1.9, so it'll be outside 1.1 parentheses 1.1 plus 1.9, and I get 3.3. Did I do that right? 1.1 times 1.9. 1.1 times 3 is 3.3. 0.8 times 8.8 plus 4.2 is 4. Huh. Okay, so again, it must be, you're probably thinking I'm crazy, but it must have something to do with the way this is set up. So let me check my measurements on screen here and check, see what's going on. But the formula is, so I guess it'd be better to have just created one yourself and checked it rather than to measure. And all right, so if I put this here, okay, I am off. Or am I? No, it looks like 1.1. C is 1.1. Oh no, that's this one here. That's right. And then if I measure this, that is 1.9. Put this back at 0, rotate. .5, 0.6, 0.7. Well, that's 0.7. I don't know if that's going to make much of a difference. This is 0.7. And you might get different values on your paper because, of course, like what I said. And 0 all the way out to 4.9. Okay. The full length is 4.9. So 4.9 minus 0.7 is 4.2. So let's try that value again. So it'd be 0.7 times parentheses 0.7 plus 4.2. And that gives me 3.43. Okay, that's better. I'm closer to that 3.3 on the other side. So it should be exact. So that is what is going on. And then if I finally take that last one, outside is 3 times outside plus inside. And that's 13.2. Over here, if I take the outside, it's 3, multiply it by 3 plus the inside, which is 1.4. I should get 13.2, and I did. So that one was exact. So that is the formula. It just didn't work out exactly up here. So again, this is A times A plus B equals C times C plus D. Okay. Okay, page 4. Now we're just going to put it all together. This will be like a reference for you to prepare for quizzes and tests. You do need to know these formulas. Okay, so here we go. So here is a diagram. That is an angle that is inside the circle formed by two chords that intersect inside the circle, but they're not at the center of the circle. So what came to the conclusion is that A times B equals C times D. So how do these two shapes overlap? Okay, so here's what we say. It is two secants intersecting in the interior of the circle. Okay, and the relationship between them is A times B equals C times D. So this piece times the other piece of the same chord equals one piece of the other chord times the other piece of the other chord. So A times B equals C times D. Okay, now in this diagram, we have two secants that meet outside the circle. So let me bring that in. So it's two secant lines intersecting in the exterior of the circle or outside the circle. Okay, so what's going on there? Well, when we have two secants intersecting outside the circle, then we take the outside, and this is what I always tell my students. I always tell them outside times the whole thing equals outside times the whole. Okay, and that's what I have them remember. Outside times the whole thing equals outside times the whole thing. So looking at this segment here, this secant here, the outside is A. Outside times the whole thing is A plus B. Equals the outside on this line segment or secant, the outside is C, and the whole thing is C plus D. So it's A times A plus B equals C times C plus D. Okay, and now we have a secant and a tangent intersecting at a point outside the circle. Okay, so this one's a secant and a tangent, and let me bring that verbiage in. Okay, we're coming right up. So it's a tangent and a secant intersecting at the exterior of the circle. Okay, it's outside the circle. So the same rule applies. It is going to be this again. That way you don't have to memorize two rules. But watch what's going to happen in this one. What's the outside of this one? Well, the outside is A. It's the tangent. Ignore this piece right here that just continues forever and it's got nothing to do with this. Our segment is touching the circle right there. So segment A just goes from here to here. That's the outside. So it's A times the whole thing. Well, the outside is the whole thing. So it's A times A equals the outside of the other side is this segment here, which is just called B times B plus C, which makes the whole secant, the outside plus the inside, which is B plus C. But if we simplify this, anything times itself is considered squared. So A squared equals B times B plus C. So there is the formula for a tangent and a secant. So it's the tangent squared times the outside. Tangent squared equals the outside times the whole thing. But outside times the whole is squared when the tangent's equal to the outside. Make sense? Hopefully? Okay. So that there is the everything in a nutshell about chords intersecting, secants intersecting, and tangents and secants intersecting. Okay, page 5, is it 5? Yeah, page 5 brings us to the end of lesson 16. Review the lesson summary and the relevant vocabulary and go to your problem set.